So I'm making this video for this assignment because a lot of students are having issues with the live tables. So right here, it's going to ask you, what is the probability that Jacob, the newborn you're considering for a 30-year policy, lives to be 30 years old? Jacob is not Hispanic, white male. So look in table 14. All right. So what you're going to do for this one is go to table 14. And to do that, just scroll down. It's a few pages in right here. So we're looking for table 14. So we'll just click right here where it says live table for non-Hispanic white males, 14, you see right there. All right, and so then it's saying right here that he lives to be 30 years old. So out of 100,000 people, this amount live to be 30 years old. And so you just go over here to where the 30 is, and whoops, right here, you see that number is 97,424. So that right here would be the answer to part A. And I'll share this with you, the answer key right here. You will see that that is the way it is set up. And so that is a freebie for you all, this first one, but they're not all going to be done like that. This one was out of that 100,000, but the next one right here, you see, asks, what is the probability that Carol, the 44-year-old you're considering for a 20-year policy, lives to be 64 years old? Note that this is a conditional probability. So another way of saying this is that what is the probability that Carol turns 64 years old given that she turns 44 years old? So Carol is a non-Hispanic black female. So look in table 18. And so that's the thing to remember, y'all, is we're going to have to look up two numbers for this one. You're going to have to look up when she's 44 and then at 64. So at on table 18, let's go ahead and look at that 44 years old. So table 18, and then come back over here. Oops, there it is. And then we're looking at table 18 for non-Hispanic black females. So click on that. And then the first one was 44. And so the number we're looking at right here is this 94,944. And so I wrote this number, I wrote the number down, 94,944. And so that is going to be what our probability is going to be out of, right? So basically that's the denominator on this fraction. So now let's find the numerator, or the number that goes on top. And so in this case, that is 64 years old. So let's see. Let's find that 64 years old. And it's right here at the bottom. And so that number is 81,234. So we'll write that number down, 81,234, and that's divided by 9,441. And the answer to that division problem is all right. And so after working it out here on the calculator, the answer we get is 81,234 divided by 94,944 equals 0.85560. And so that will be the answer. And I'll share this one with you too, the answer key, since we already came up with the answer. So from a randomly selected population of 100,000 non-Hispanic black females, 94,944 survived to the age of 44, and 81,234 survived to the age of 64. So again, we use the table to find those numbers. I need to consider the probability that Carol will live to 64, given that she's already 44 years old. So given that she's 44 years old, the probability that she turns 64 is at 0.85560. All right, so the rest you can do on your own. You'll do the rest similar to the one that we just did, where you're finding the 25-year-old and then the 55-year-old on the table. Remember, y'all, that he is a Hispanic male, so you always want to go back to your tables. Let me just zoom this up right here. And then this is where you would find the looking for Hispanic male, so you would go here. All right, and so that is how you do this task for your assignment.